There are 3 steps to solving rational equations. First, we have to find the LCD. Then we have to multiply through by that LCD. And lastly, solve the equation. We're going to use the same 3 steps in each example. And here they are. They're up in the upper right corner, so you can use that as a reference. We're going to start by finding the LCD. In order to be a least common denominator, that means that each of the denominators that I see here can divide into it. So, something that you first learn to do when you're doing common denominators is just multiply everything together. But if I were to multiply everything together, I would have 3x times 7x would give me 21x squared. I don't really need an x squared. I just need an x term for this to be able to divide in and this to be able to divide in. So if I look at just the number part, both of these numbers will divide into 21. If I look at just the variable part, both of these x's will divide into x. And then the expression, the binomial I have here, will go into itself. So my LCD is going to be 21x times x plus 4. That way, this term can divide into this denominator, this term can divide into this denominator, and this term can divide into this denominator. So the second step is to multiply through by the LCD. So I'm going to take each term and rewrite it and multiply by the LCD on top. So I'll have 3 times my LCD and then 1 times my LCD and then 10 times my LCD and now I'm going to go through and cancel wherever I can. So I can cancel the 3 and the 3, and those both become 1. I can also cancel this x and this x because they're all being multiplied together, remember. In the second term, or the second addend, I can cancel the x plus 4s. And in the sum, over here on the right, I can cancel the 21x and the 7x, and then this would become a 3. So now I'm going to write what I've got left. So in this first fraction, I have a 21 times x plus 4. Everything else is just 1s, right, because I canceled everything else out. So 21 times x plus 4, I have to distribute. 21 times x and 21 times 4. So for that, I'll get 21x plus 84. All right, the next fraction, all I have left is a 21x because the rest canceled. And in the sum, I have a 30, because I have 10 times 3, times this binomial, so I have to distribute again. 30 times x, 30 times 4. And that would give me 30x plus 120. And now I have an equation with a variable x, and I'm going to solve. So I'll combine like terms. On the left side, I have 42x plus 84. On the right side, I have 30x minus 120. I need to get everything over to the same side, so I'll subtract 30x from both sides. And I'm also going to add 120 to both sides. So I'll end up with, actually, you know what? I'm going to leave the 120 there for now because if I'm going to solve it, I'll need that to be on the other side. Okay. So when I subtract, I get 12x equals, oh, hold on, 12x plus 84 equals negative 120. I'm going to move it up here so that I have more room. So now, instead of adding 120 to both sides, because then that's going to give me 0 over there, I'm going to subtract 84 from both sides. So now I have my x terms on one side and my number terms on the other. I have 12x equals negative 204. And I divide by 12. And this is my answer, negative 204 over 12. Now, I can simplify that fraction. I can divide the top and bottom by 4. So if I divide the top by 4, I get negative 51. If I divide the bottom by 4, I get 3. And actually, these are divisible. So 51 is divisible by 3. So I would get, let's see, what is that? 3 goes into 5, 1, 2, 17, I think. Negative 17. So that would be my final answer. All right, let's do another one. So first I need to figure out my LCD, and I'm going to do that by multiplying my denominators together. But there are two that have a common factor. So when I take x squared minus 9 and I factor it, I get x plus 3, x minus 3. So if I were to multiply all of my denominators together, I would have x plus 3, x minus 3 for the first denominator. And then I'd have another x plus 3, and then I'd have an x. Now, I don't need to have x plus 3 in there twice. So I only need it once. So I'm going to get rid of this one. I could get rid of either one, but that means that my LCD is going to be x times x plus 3 times x minus 3. So now I'm going to multiply through by my LCD. So I have negative 2 times x, x plus 3, x minus 3 over x plus 3, x minus 3 plus 3 times my LCD equals 1 times my LCD and now I go through and cancel as much as I can. So in the first fraction, the x plus 3's will cancel, and so will the x minus 3's. In the second fraction, I can cancel x plus 3. And in the last fraction, I can just cancel the x. All right, so now let's write what we have left. In the first fraction, all we've got left is a negative 2x. In the second fraction, I have this 3x over here that I need to distribute to the x minus 3. So I get plus 3x squared minus 9x. And then in the last fraction, I have just this part left. And we know what that equals when we FOIL it out. It equals x squared minus 9. We want to keep, since we have an x squared term, that means it's going to be a quadratic, which means we need to get everything over to the same side and set equal to 0. And I'm going to keep my x squared term positive. So I'm going to subtract x squared from both sides, and I'm going to add 9 to both sides. So I'm going to I'm going to subtract an x squared here, and I'm going to add 9. I'm going to write it over there because it doesn't have any like terms. So when I do that, I start with my x squared terms. 3x squared minus x squared gives me 2x squared. And then I look at my x terms. I've got a negative 2 and a negative 9, which is negative 11x. And then I have my plus 9 sitting over here by itself, equal to 0. Now that I've got a quadratic, I've got options. I can factor, I can do quadratic formula, or I can complete the square. So I'm going to try to factor. It's going to have to be a times c factoring. So 2 times 9 is 18. And I need 2 factors of 18 that will add to be negative 11. So that's going to be negative 2 and negative 9. And then I'm going to do a over. So I'm going to do 2 over negative 2 and 2 over negative 9. This will simplify to 1 over negative 1. And this fraction stays the same because it's already simplified. So then my 2 binomials are x minus 1 and 2x minus 9. I now have to set each of these equal to 0 and solve. X minus 1 equals 0 and 2x minus 9 equals 0. Here I'll get that x equals 1, and here I'll get that x equals 9 halves. Should always look to see if you plug these back in, if they're going to give you 0 in the denominator, which they don't. So we're good on all accounts with both of those solutions. So we have 2 solutions for this rational equation, and that's it.